If you clicked on this video, it's probably because you're planning to take the October PSAT, the October SAT, or even the November SAT. Make sure you stick around because we're going to be reviewing a couple of problems that you potentially could see. Please note the disclaimer listed below, and before we get started, another note, these problems are going to array in complexity. This means that some of the problems might be easy, medium, or hard. Make sure to check out the timing of each one of the questions so that way you can review each problem and understand how to solve the problem for yourself before you take the exam. Sometimes you might be seeing a problem you already know, sometimes you might not. Either which way, make sure to check out the chapters so you can scroll where appropriate. Okay, now let's get started. So as you can see here, I have a question here and it says the expression 24 over 6x plus 18 is equivalent to 4 over x plus b, where b is a constant and x is greater than 0. What is the value of b? Now, you might be thinking that you could set these two equal to each other, essentially saying that this is equal to each other. But note that you have two variables, and this is something where you can solve faster by using Desmos in this type of problem. So before we get started with the nitty-gritty of it, I have a picture of a keyboard here. This is a Mac sample keyboard. This does not mean that you have the same keyboard, but I want you to note two symbols here. The first symbol is this symbol right here, which symbolizes a little equivalent sign. So you're going to use that for not equals, but for this symbol of equivalent. And I want you to note the two symbol brackets here, which symbolizes this and this. And you should be placing this into Desmos like this. So essentially, when we go ahead and type it into Desmos, you're going to see that we're utilizing this bracket and we're using the little squiggly line here. Okay, so let's type this into Desmos now. I have my little calculator here and we're going to go ahead and type it into Desmos so you could better understand how to solve for the problem. So firstly, I went ahead and just quickly typed in the equation. So I have the bracket symbol, 24 over 6x of 1 plus 18. So you might be thinking, how do you get the x of 1? The way that you essentially can do that is by going ahead and typing in X, and then if I erase here, you just type in 1, and as long as there's no space bar or anything like that, it will go ahead and populate for you. Same thing with the second x, you want to replace it with x1. Desmos doesn't like to see x by itself, so anytime you utilize any variable x, you are going to replace it to let it know that it's the first x. Now you have that little squiggly symbol in between, and make sure to put the brackets and you just hit enter, and then it will tell you b equals 3. So because of this, we know that our answer is going to be b equals 3, or answer choice C as the correct answer. So you can see here, this is a pretty quick and easy way to solve this type of problem. So you can simply type into Desmos. Let's try to solve the following problem together. This type of problem involves multiple choice where you have to solve a problem, but it's not really clearly stated what they're looking for. So let's take a look together. They talk about Maya, who's only growing apples and pears in her orchard, and last year she harvested 200 pounds of apples and 100 pounds of pears. So off the bat, you might think it is a problem where you have two variables, but let's keep going. It says this year the production by weight has declined by 21% and the production by weight of pears has declined by 40%. So we have apples and pears and we are comparing pounds to pounds and percentage to percentage. And they want to know what percentage did the total yield by weight of Maya's orchard decline. So let's talk about last year. So I will have LY here, and they wanted to know what the total yield by weight is. So what is the decline from last year to this year? So last year to this year. So we have two different time frames that we're talking about here. So when we talk about last year, we're talking about the fact that they harvested 200 apples and then 100 pears. So I'm going to put apples here and pears. So the total for last year was 300. And remember, we're talking about weight, so I'm just going to put total weight here. Then, if we're talking about this year, they want to know what it's going to be, but we know that the production has declined. And we know that the amount of apples have declined by 25%, I should say, and by pears by 40%. So in actuality, this year, we have 200, but it declined by 75%. So times 0.75. Remember, we say 75% because we know that we're declining by 25%. However, we're still growing by 75% because we take 100 minus 25. And because of this, that leads us to 75. We want to know the total growth because we're growing apples. We're not decreasing apples. And so because of this, I have 150. Now I can do the same thing with my pairs, subtracting 100 from 40. So 100 from 40, that's going to give me my leftover percentage. So that's going to be 60%. And that's from the 100 pairs that we have from last year. So if I put that into Desmos or just quickly calculate, I know that's 60 because 100 times whatever value, it's going to be the same thing. Just put two decimal places to the left, and that's going to be 60. So my total yield this year is going to be the sum of 150 plus 60. So that's going to be 210. So when they're asking, they're looking for the total decline. So how much did it drop by? So I know this year I have 210 and last year I had 300. So basically I'm just subtracting the two total weights from this year to last year and I get 90. Now they want to know the percentage, right? They want to know the percentage. They don't want to know the total pounds. So 90 would be just the weight. However, we want to know the percentage decline from the original. So it's part over whole times 100. So our 90 over our original or total weight is 300 times 100. So that's going to, if I type that into Desmos, give us 30. So the best course answer here is 30. So that would be something that you would get where you have to create your own table and you're given a lot of information to try to deduce or come up with a projected answer. Now, key things to indicate here, if you are given a PSAT or SAT question, note that they're talking about some sort of growth. Like in general, products like apples and pears or students, they usually increase in growth. They're still growing. We're comparing the growth from one year to the next, which is why we have to subtract the percentage. So make sure that you take a look, that you're not being tricked by overall words like decline, where you might go, okay, 200 times 25%. And you have to think to yourself, it says it's declining by 25%. That means that it's still growing by 75%. So you want to go ahead and take a look and calculate that. And this is more a combination problem of understanding two different factors or systems of equations, you could say, but also utilizing percentages at the same time. So for the new digital SAT and PSAT for this year, specifically October, November, and even December, There are going to be problems that you achieve or attain that require you to take a look at two different scenarios or two different concepts together. And this is an example of that. So making sure that you understand that even though you have some sort of decline, you're still growing. So for example, if they say someone's height, they increased by 20%. That height is increased by 20%. But if they said it declined by 20%, we're still growing. So we need to flip it. So making sure that we still understand that there's 80% growth overall. Let's take a look at the following problem that you see here. So in this, they take a look at a rectangle and they're asking about a ratio. So what I think is going to happen this fall, specifically for the October, November, and even December SAT and PSAT, is for the math section, you're going to see multiple concepts being tested at the same time. So if you look at the College Board concepts, they might say, okay, we're talking about geometry, and we're also talking about trigonometry and ratios, which are three different concepts being tested simultaneously in one problem. And this problem gives an example of this. So firstly, they let you know that there is a rectangle. So I'm going to go ahead and draw the rectangle here. Also note, I've been noticing that a lot of triangle and rectangle or just shape problems in general don't actually display the shape in the problem, especially with the updated questions that have been provided by College Board in terms of examples that they provide. They're not really providing the shape itself. It's very rare that they do that. And I think this is because if you are looking on a computer screen, it takes time to open up a paper or just draw out the shape. So that's going to take time. So instead of providing hard problems, they're giving easier problems, but a lot of work on the back end. So that's another trend that I've been noticing as well. So you can see here, they talk about a rectangle and they let you know that there is a diagonal. And they also let you know that this diagonal is 2 square root 85. So off the bat, you should know that these are 90-degree angles on either side. And if you cut this in half, this means that this is going to be half of 90 on each side. So 45, 45, 90 triangle, right? So the other thing to note is you can see here I had to deduce that there were 90 degrees on four sides of a rectangle. Previously, for the digital SAT or previous problems, before the digital SAT, they would provide the 90-degree angle, and you don't see that here. So I just want to point that out as an update. They let you know that the shorter side to the longer side is 3 to 4. So this is a ratio. So for every 3K, they let you know that there's a 4K on other side. So they're letting you know that, and they want to know what the length of that longer side is. So now you have to use the Pythagorean theorem, which states a squared plus b squared equals c squared. And you can go ahead and type that in. And when you do that, you get 3K squared plus 4K squared equals what we're trying to find out, which is the length of the rectangle's longer side. And I'm going to go ahead and simplify this because we are also told what the diagonal is, which is going to be 2 root 85. So we're told what that diagonal is. So a squared plus b squared equals c squared. And we're going to go ahead and figure out the left side here and simplify this further. Um, because this is technically all squared, I'm going to go ahead and simplify the left side and make sure that's equal to the right side. So I can go ahead and simplify this by taking the square roots of both sides, and that eliminates that. But remember, I'm going to take the squares of the inside, right? So we have square root. 3 squared is going to be 9k squared because I distribute that 2, plus taking the same 2 and distributing it. So 4 squared is going to be 16k squared. I can simplify this further, and I can go ahead and say that this is square root of 25, 9 plus 16, because they're both the same variables, 25k squared. And if I simplify this further, square root of 25 is 5, and the square root of k squared is just going to be k. And this, because we took the square root of both sides, is going to be the same thing as 2 square root 85. So essentially, if I go ahead and go to the next step, so I'm going to erase what I have here to give myself some space. We solved that out. Now I'm going to say that 5k equals 2 square root 85. You could plug this into Desmos by dividing 5 from both sides. When you go ahead and simplify that, you will get something along the lines of k equals 2 square root 85 over 5. You could plug this into Desmos and simplify to a decimal format, but because I'm just going ahead and I need to find the longer side, remember it's 3K on one side and 4K on the other side. I'm going to go ahead and solve for the longer side, which is 4 times this whole value. So essentially what I'm doing is saying that I'm timesing this by 4 because it's K times 4. When I go ahead and do this and I multiply it through and I simplify it in my graphing calculator, or you distribute the 4, you get 8 square root 85 over 5. You can go ahead and plug this into Desmos if you wanted to simplify it, so you can plug it into Desmos if it's a multiple choice question, and you can go ahead and solve for the decimal form, just making sure that you round appropriately as needed. But this is the final answer if you were to leave it as this and if it was a multiple choice answer. So basically this problem is testing your concept of understanding multiple things in the same type of problem. I also want to note that if you were to convert this into decimal, you would get something like 14.714. In this problem, it doesn't say to round or anything like that, but if they did say round to the 10th, it would be 14.7 hundredths or thousandths. You would round appropriately. But this would be the decimal form if you were to go ahead and convert it. And the other thing to note is they're asking for the longer side. So make sure to understand that problems you could see is one, problems where you're not given the actual shape and you have to draw it out yourself. Two, comparing multiple concepts. So we're comparing geometry and algebra or analytical thinking with the ratio and this understanding of also utilizing geometry. So these are some of the concepts that you can learn where you have multiple concepts tied into one problem.
Appreciate you riding along for our cosmic journey. If today's mission brought you the knowledge that slaps, make sure to hit that like button to boost that signal. Subscribe if you're locked in for our next launch. And don't miss the link tree. It's got all the goods for AP Bio, PSAT Math, and SAT Math. Before I sign out, make sure you're all in one orbit and diving in. Killing out. Till next time.